Tobias, there's a lot of conversation about dry fiber right now, and I know it's in the early adoption phase for a lot of manufacturers. But from a kind of engineering point of view, what does dry fiber forming actually mean, and how is it different from other types of forming like pulp molding?
Well, Dean, the difference is already in the name because the name says it's dry, the fiber. When you compare to traditional wet pulp molding, you have the fibers divided in a pulp solution, like 2% of fibers, and then you suck them out as a form part, as a packaging form part, and then you have to get rid of the water. You have to press the water out. You have to dry it with heat, and that's not happening in dry fiber at all. In
Mm.
dry fiber, we have the fibers, almost at air humidity level, and we just press them in a form. And by pressing and applying pressure and heat, we form the form parts and have no water involved in the process that we have to dry. So the energy consumption and also the process time are much faster for dry fiber processing than for wet fiber, and that's a big advantage for the industry because it's always about output and process efficiency, and this is what dry fiber gives to the customers.
What do you mean by faster? What element is faster and why?
Well, the forming process itself is faster. You don't have to wait for the time until the fibers are applied to the vacuum tool, and you don't have the drying steps afterwards in the process. You just put a blank onto the machine, so to say. You form it, and then you're finished with the part in only some seconds. So much closer to thermoforming from the processing time as to wet fiber.
So is it more closer to thermoforming speeds? Would you say?
Yes, it is. But to be
Mm.
honest, of course, the process have some drawbacks in the efficiency and in the process time. Um, a really elaborated thermoforming process is faster than dry fiber at present maturity level. But yes, as said, we are much closer to thermoforming. We can almost keep up the pace with thermoforming in terms of productivity. So the machines we use can go up to 15, 18 cycles per minute, depending on the part design, of course. With a multi-layer setup on the tools, you can reach an output of 10 to 30 million a year with the actual designed dry fiber line. And this really meets, from our perspective, the output of thermoforming lines and also the output, of course, of startup scenarios, because I don't think customers will step directly into billions of numbers of produced form parts in dry fiber. They will ramp up product by product and market by market, and this is exactly what our dry fiber lead line is addressed to.
So there's some obvious benefits with dry fiber from an environmental perspective, and there's obviously a bit of a mix in the brands whether they want the product to be shown off in plastic or a hybrid solution, or actually go down the full environmental route. And a lot of that is down to pressure, isn't it? But when a customer finds, when a customer comes to you and asks about dry fiber, what's the first thing that you find? Well, the first questions they ask you, and what do you find yourself telling them?
Well, in the past, when we started with this initiative, we experienced that the customers are really experienced in fiber applications. Some of
Mm.
them come from pulp molding and are a little bit disappointed because they do not meet the cost numbers for their output or for the machines and for the form parts. Some of them have heard of dry fiber in news announcement and from other people, other players in the market. And the question is not about if fiber packaging is useful or makes sense. I think brand owners and converters know that very exactly because they are also bound to legislation and to the market expectation of the customers. They want to know what ILLIG is capable to do in fiber, and this is where our development comes in. We are the only ones in the market, and it's our USP that achieve a very high drawing depth. So we open the technology to a much higher number of applications, so to say dairy products or FMCG packaging goods, and also a design flexibility is given by the high drawing depths that we can achieve with dry fiber. So this makes it very attractive to the customers.
Are those questions along the lines of things like drawing depth and things like that that they may be surprised from the early iterations of dry fiber to where we are today with your machine?
Of course, it's always about the cost. That's also one of the main questions, and I think we can get closer to this afterwards. But then customers are surprised that we can achieve the high drawing depth. We have it in lab scale in our laboratory, so there's a completely automated DFM laboratory machine that can showcase the drawing depth and the forming flexibility of the process technology. Customers are surprised what they see in the laboratory, that we are able to achieve that deep drawing depth in comparison to the competition on the market and to other players. And this is what's really surprising the customers at ILLIG, that we can do this and we can do it automatically. And at present, we are working on the scale up, so rise the numbers of cycles per minute and make it really an industrial capable process.
Talk about your flagship dry fiber machine initially, which is the DFM 100. So let's talk a little bit more about that in terms of from an engineering perspective on the shop floor. And so obviously cycle time is a well-known term throughout engineering and manufacturing. So the cycle time, how is that different, or how is that in a competitive way as good or better than other forms of forming?
Well, cycle time, of course, is one key factor for high productivity and production efficiency, and also for the cost point, because you have an invest into the machine, which is you can say kind of similar to a thermoforming machine, tool and machine equipment. And then cycle time is about productivity and output of the machine, and we have multiple tooling setups. We try to raise the cycle number with a DFM 100 machine to an industrial capable process level. And then, of course, it must be about total cost of ownership. It's not only the machine and tooling and the output, it's also the material cost and labor effort you need to drive the machine. All of these things matter. And this is what we try to achieve with our long-term experience in packaging. We try to deliver a solution to the customer which can be used in an industrial environment, which is also what the customer can earn money with, and what's working for their scenario of processing.
I see that as quite a unique advantage for ILLIG, because we are a typical machine builder, because we have been in thermoforming, we've been in packaging for such a long time. We have that experience of what it takes for customers to benefit from the machine manufacturing side, from the production side of things. So the fact that we're bringing that into the dry fiber, where some of the market out there is coming from sort of the development side of things, not necessarily from the machine side of things. So that's a bit of a unique thing from us. I also think the dry fiber for ILLIG solution, if you look at the world and the circularity and the need for sustainable production, the fact that we're not using such a mass amount of water to reduce fiber packaging, we are actually getting closer to that circularity and that sustainability.
Also, the environmental footprint counts more and more from my perspective. What I hear from talks to customers and to people related to packaging, it's more and more important.
What about the machine itself? I know some of your other ranges have a very modular approach when it comes to tooling. Is this the same on your dry fiber machine, the DFM 100?
Not really. Of course, we try to transfer all the experience we have in thermoforming machines to dry fiber as well. So you have a very modular machine. You have an HMI, which is kind of which the customers are kind of used to. We adapt quick tool change technologies to the machine, that also the machine can have more uptime a year, and is not stopped by tool changes or maintenance so much. So these are the things that we do in thermoforming since decades, and what we transfer to the dry fiber approach as well, of course. Tooling is a little bit different, because we have a form press process with a male and female forming tool, which is different to thermoforming, because dry fibers are like a loose web. You can imagine, which is formed by geometrical contact to a tool surface, not by vacuum or air, because it's not leak tight, of course. And therefore, we had a different approach in the tooling, which we had to develop completely new in the recent years. But on the other hand, I think a process engineer of thermoforming will get to know very fast how it's working and get into the process specification, and will adapt very fast to dry fiber processing. Because at the end, there's a packaging form part as a result, and that has a specification for the use in practical supermarket or point of sale. And this is the same like for a plastic form part. So the result counts in that case, and I think the process is just the path to get the result.
We've spoken a little bit about productivity, cycle time, cost of ownership, ease of ownership. Well, I want to talk about ease of ownership in a second. And we've talked about the potential impacts for the environment or less impacts on the environment in the dry fiber forming itself. But on the DFM 100 itself, if somebody's looking at investing in machinery and they're looking at contrasting it against wet fiber machine, what's the footprint like compared to the DFM 100 from a wet fiber to dry fiber? Do they need more space for wet or is it more space for dry?
That's a good question, Shmi. Thank you for asking. The modular dry fiber approach is, I think, very clever in that case, because we have a machine which is one single line of some 20 meters length, I would say. You can start from a roll, which is manufactured at the allied producer externally, like in thermoforming when you use the extruded sheet. And then you can process that roll through the machine and make packaging form parts. In wet fiber, you have to invest into the mixing equipment, which is called a pulper, where you mix the fibers with the water and add chemicals and all these things. And these pulpers normally are very largely designed. So one pulper needs, I would say, 4 to 6 machines for forming to be economically in its process. And this is not necessary in dry fiber. You can start with one single machine, produce your parts, and if it comes to a ramp up, if you need a higher output, then you can add a second machine, you can add a third and the fourth machine, and so on. So the modular approach gives you the possibility to enter at a very kind of or comparatively low cost point and investment, and scale this up by the numbers of products needed.
What about for the people that work on the shop floor, the operators? So if somebody's been running a thermoforming line for 10 years, what's the difference about running a dry fiber? I know there's a benefit if they've already got ILLIG machines in-house, because from what I understand, it's the same control system, right, across all the range. But what's the difference for the things like retraining? Is it a difficult step?
Customers will adapt to that very fast, because on the input side, upstream side, you have the roll with the allied material. Of course, it's behaving different than a plastic sheet. You have a preparation station, so the process is divided into 4 steps. First of all, out of the roll, we cut out pre-cut blanks, which meet the surface and the geometry of the finally formed part. Then we do a pre-form process where we push the fibers into the correct position and achieve the forming depth. So the fibers are not stretchable or elastic like thermoplastics are. So we have to push them into the right place. And after that, after we have done this, we apply a pressing step with pressure and temperature, and we consolidate the part to be a solid packaging form part. Last step is cutting of the rim, that we have a clean and smooth sealing rim in the part. And of course, then you can add all the end-of-line options that you know from ILLIG: stacking, packing, decorating, whatever you can imagine. This is common sense to the use of ILLIG thermoforming machines. And then when it comes to the machine layout, the preparation station, which is kind of different from a thermoforming machine, but I think very easy to understand, because it's a punching machine which cuts the blanks out of the web. Then we have the 2 forming stations, which are very similar to the ILLIG RDK or RV line machines. And we have the punching station as well. So this process will be understood very fast. And then it's about the tooling, of course. The tools have to be set up correctly, have to be aligned. But I think as we gained a lot of experience in the last years developing that process from manual single lab scale over an automated DFM lab process and now finishing the DFM 100 line, we can support the customers very well in training and process knowledge and technology on that point.
Tom, have you got anything that you would like to add around the training or any of the tooling that Tobias has mentioned?
I guess the thing is we've had active customers already take on some of the lab machines to do their own testing, do their own developments. So we have a bit of a blueprint, shall we say, of how we brought them into house, how we got them set up on that, how we got the operators set up on that. So we have a current blueprint that we can use, and we've refined, defined to make it as easy as possible.
Tobias, what does dry fiber forming actually mean for pack design for clients? What does it look like?
Well, it's a little bit of different approach because we have the preforming step, we have some wrinkling in the material, we have the forming step, and you cannot take a product drawing and wipe out PET, for instance, and write fiber on it. You have to redesign the part. But what we try, of course, is that we make it fit into the subsequent processes, like filling, labeling, sealing, whatever. So we try to not change the functional geometry of the parts, the sealing rim, the outer diameter, the shape. We try to adapt the fiber modifications into areas where it's not important for the functionality of the part. But of course, we have to redesign the parts slightly. But on the other hand, with the process we can match a lot of designs that are already on the market, like 500-gram yogurt cups, 150-gram yogurt cups, meat trays, battery packages. So a lot of shapes can be transferred to fiber into the process we use and then be used as a packaging form part for the same application.
So you mentioned a slight redesign of elements there on behalf of the customer. Let me talk about and ask you both. This is something we do a lot for clients, isn't it? But we don't really shout too much about it, where we actually, not necessarily with the manufacturing teams, we're with the design teams talking about the best ways to build their packs for a certain format. Do you want to talk a little bit more about that? Do you want to start, Tom, and just talk a little bit more about what we do on that side, which isn't just selling machines, which a lot of people think ILLIG do, develop and sell machines. We're actually at the front end with the design team. Can you talk a little bit about that for me?
Yeah, sure. So we obviously have a packaging lab within the Germany headquarters, and in this environment, we can bring customers in. We can look at existing drawings. We can talk about their specifications, what their requirements might be. So it could be they have a top load requirement, or they need a certain definition. All of this stuff can be discussed at that stage, and we can also then help with designing those, or help contribute into the designing of that packaging to make sure that they're going to receive a machine and a product at the end of that machine. And then that works for their customer, it works for all the downstream equipment, and so on and so forth. So it's good to get us involved at the very start, certainly when they're just looking at sort of redesign or packaging design. And it's even more critical when it comes to the dry fiber side of the topic.
Tobias, do you want anything to add to that, seeing as you're based over there in Germany?
Yes, of course. I think from my experience of 20 years in manufacturing industry, it's very important to involve the machine manufacturers and also maybe the material side when you have a new product. The projects where you do this are the most successful ones because everybody can bring in his own expertise in his area. Our expertise is automation and form part production, and we can see the design the customer gives us. We can make modifications in that early stage, adapt it to the machine, to the process, to handling systems, whatever you can imagine, and optimize the form into this direction from the process engineers perspective. Of course, there's the designer that want to have a certain appearance in the point of sale. It should look nice and attract the customers. But at the end, it has to be manufacturable. It has to be produced at a affordable cost point, and that's what we can assist on that point.
Let's move on to something that's a bit of a balancing act between environmental and functionality. Let's talk about coating. Can you coat dry fiber? Would you do it? When would you do it? You know, for things like chilled foods, obviously there needs to be some coating embedded onto there. Talk to me about how dry fiber works in that environment, or is it just for dry goods?
This is a little bit challenging, I would say. So when you look at plastics, they bring every barrier with themselves inside the material, have low processing temperatures, are good in formability. You can do a lot of shapes and geometries. So plastic is one of the ideal packaging materials. In fiber, we have the possibility to produce form parts, which also look very nice and are very functional. But of course, cellulose fibers do not bring any kind of barrier with themselves. So we differentiate, meanwhile, with our experience between a basic barrier that's protecting the material itself from storage, humidity in transport, maybe some spread water. And non-food goods can be packed into this kind of material from the scratch. If you take a look about the use case, maybe for takeaway food or also for dairy food with a certain shelf life, this gets more complicated because you have to adapt the barrier to meet the requirements exactly for that. So if, for example, you fill in hot soup, the material has to withstand the fluid, has to withstand maybe fat, has to withstand the heat, but it only has to withstand it for a certain time until the food is consumed, and then it goes into the trash bin or into the recycling. For materials or for parts with shelf life, it's more complicated because you have to keep the aroma inside, you have to keep the shelf life of the food inside, and this I think is the most difficult thing. For applying these barriers, we have different approaches. The basic barrier can be incorporated directly into the airlaid material. We had a lot of successful trials in the past weeks for that, and think we are close to the goal. And for food packaging, laminating could be one approach, which is already developed. Plastic laminating films have already food approval, and all the legislation is met for those. So if you want to be a first mover inside the shelf, you could laminate your parts with a plastic film and have the barrier inside the form part for packing anything you want inside.
Tom, do you want to cover anything about the industry standards and where we are with that on this one?
Yeah, I think obviously from a plastic packaging side, Tobias said it's got the aspect of the barriers already for food, but the plastic packaging is changing within the market. So certainly on a UK perspective, there is obviously a plastic packaging tax that's coming in from 1st of April. That is very much focusing on anything that's under 30% recycled content. And then from April 27, there is also going to be pre-consumer waste. So any offcuts within the factory setup of that plastic will stop counting towards that threshold. And then there's also the plastic EPR that you've got to look at. So in year one, there is a flat base for plastic, which then that's already starting to tilt the economics against plastic. So from year two in 2026, 2027, the fees get moderated on a red, amber, green recyclability rating. The red rated packaging, they pay sort of a X times base in the first year, and then in 27, 28, that X times increases, and then it increases again in 2028 and 2029. So that is, the plastic is structurally getting more expensive while we develop the fiber and the fiber matures and we start getting more and more development in the coating, more and more development on the dry fiber. There is an aspect of where regulatory is shifting that field, that vision.
If a customer wants a pack with the same barrier performance as CPET, is dry fiber there, or can it realistically get there?
Well, honest answer, to date, I don't know. Because when you look at the scope of CPAT, it's very heat resistant. It's maybe for oven meals, for hot filled sealable trays, and we didn't develop a barrier for that at that time, and we do not have it on the roadmap as well, to be honest. Because first of all, we cover the things that we can achieve with the technology we have, and I don't think that anything should be pressed into a certain material or technology. There are materials that are very suitable for packaging certain parts or being in a certain application. And I would not force anything to go anywhere with a bad compromise, so to say. I do not want to say that dry fiber is a bad compromise, but to date we have other challenges that we have to solve, and we want to reach markets that are quite remarkable numbers of form parts. And CPAT is there and is working, so I wouldn't replace it right now. If in the future it is possible, sorry, I don't have my glass ball here, but maybe.
Tobias, if you had to draw a map of which packaging categories that dry fiber would really, really suit today, where would you put the dry fiber categories?
As mentioned before, we can reach a lot of markets and a lot of part designs with the process we have developed. And first of all, of course, I would like to reach the non-food market, because there only the basic barrier, as mentioned before, is needed. And we can achieve that, I would say, very quickly. And then we can also test the customer experience of the packaging, so sealing and reopening, for instance, also decoration. And meanwhile, in that time, develop the barrier topic further to also achieve more complicated packaging parts, like yogurt cups, for instance. We're doing that in close contact with customers. Customers as well are developing on barriers, and I'm very happy about this, because they have to do all the approval things, have to do all the shelf life tests, which are we not capable for. We do not have the equipment and also not the personal resources to do that. So I would say at the end, for a very complicated application and barrier, the customer is responsible that this works in the market, and we are the ones to help them automate it into the production process of the form parts. This is our specialty, our experience, or our expertise, and this is what we would like to support the customers with in that case. And I think out of this combination, working with customers, material suppliers, barrier chemistry, and also the machine supplier, of course, which develops the process, this is a very good composition of people and experts working together in the same direction, and I think we will be successful with that in the future.
So are there categories where dry fiber is being pushed into the certain sectors for narrative reasons, even when the case for engineering is weaker than the thermoformed rPET?
Well, I wouldn't take this perspective. I would have another point of view. ILLIG was always very material and technology neutral. We have machines for plastic thermoforming. We have machines for thermoforming hybrid parts with cardboard reinforcement and the in-mold labeling technology, for instance. We have the packaging machines from a combination of thermoform and cardboard up to 100% cardboard. Now we have dry fiber, which is an addition to our portfolio. We would not substitute anything with dry fiber. And it's always depending on the customer's perspective. The customer has specifications for the products, maybe legislation in the market in terms of recyclability or packaging material. The customer itself has customers which want to have a certain repetition of the product, or want to have an experience with the product. And we try to meet these categories technology neutral. So we do not try to push dry fiber into everything. We try to deliver the best solution that is meeting the specification and the requirements of the customer, and not forcing something into a technology that brings only drawbacks. So we do not want to deliver any construction site to the customers with a lot of problems. We would like to deliver solutions, preferably.
Tom, Tobias touched on legislation there. What's the legislation like over here in the UK? And is it any different to the rest of Europe?
Yeah, I think it's very similar to Europe, but I think like the UK, there's a push, certainly from retailers and brands. They all have their own individual scorecards that they may be pulling from the regulations, but the sustainability is a big topic point on those scorecards. So the major retailers, or even WRAP's UK plastic pack targets, they are independently trying to hit some of those regulatory timelines. So it is a narrative driven point. But as Tobias says, I think we as ILLIG, we always try and come from understand what the customer is trying to achieve, and direct them into the best way possible into production environments.
Those companies aren't replacing everything overnight to the dry fiber solution. They're testing applications, they're building experience and running fiber alongside existing processors, whether that's plastic or whether that's card. How does that look like? How does that hybrid setup look like in the factory? Let's take both of your regions. Let's take Germany first, Tobias, and then Tom will take businesses around the UK. Are they still in the state of flux in 2026 that they are a thermoforming house or a packaging house, or are they starting now to develop different technologies within it to cover everything, a bit like we do at ILLIG?
That's very different depending on the company. Some companies are very experimental and try to go into the market with new things. These are first movers, so to say. And some companies are very conservative. So we are working with companies that already have a lab machine running in their facility to do own tests with material and product development. Those are very strong drivers also for our development because we get a lot of feedback from them. And well, the transition phase, yes, as you mentioned, it will not be overnight. I think customers start with one product that maybe not a high runner, put it into supermarkets for test customers, not in the whole region of Europe, and see how the reception of the customers is at the end. Will they complain? Are there any issues with opening, sealing, reopening, the use in the shelf life, and so on? And with this experience, the development will carry on. And this is also where the modular approach of our DFM 100 comes in. You can produce some million parts a year. You can put it into a certain market, maybe a certain country or a certain region, and then see how the customer experience with the product is. And after that, we will maybe do some iterations, some improvements, and roll it out to the larger market, maybe continental area or something like this.
Tom, are you experiencing the same things in the UK with both manufacturers and OEMs?
Yeah, pretty much. So I think OEMs are keeping a very close eye on, like I say, the pressure is there to hit the sustainability goals. So they're keeping a close eye on the technology and what is developing. The converters, we're having more and more conversations with current customers who are interested in the technology. But I think it's not going to be a shift overnight. They're never going to replace whole fat lines of current plastic lines into fiber. But I think more and more people are looking at this as a sustainable approach, trying to hit those sustainability goals, and gradually move into it. And then I think there's also an aspect of new clients who are already within like a cardboard or pulp type area, that is interested in the new technology that we've developed. So certainly the depth of draw, we're achieving something different to what's in the market at the moment. So there is an aspect of conversations happening with new clients under that aspect. So, but I think the existing packaging, I think it wouldn't necessarily be replaced overnight. It's not possible.
So if someone is running thermoforming today in their factory and wants to add dry fiber without disrupting their existing output, what's the steps they should take? I mean, they might think it's a big step, but what actually is it, Tom? Is it bigger than is it as big as I'm thinking, or is it easier than that?
No, I think we've had real success with this and with current customers. So it starts with effectively a product drawing. So a lot of our customers will bring us a project drawing, and we can then start with having a conversation about how that product adapts into dry fiber. And then once we touch into that, we can then talk a little bit on what requirements is there, what is the downstream aspect, what is the product for, and so on and so forth. And then we also have a lab machine here as well. So we also have our dry fiber lab machine. So effectively, if the customer then wants to take that further steps, we can then do a sample testing and do a test tool. So ultimately, the customer can have a finished product at the end of it that they can actually then take further into the market and actually test in the downstream equipment or test at their customers for them to see the real effect.
That sounds great. So if they've got past that stage and they like what they see and they're still a bit unsure about investing in the new machinery, what's the next step? Tobias, is that where you guys take over in Germany?
Yes, we do. We gathered a lot of experience in dry fiber working in the last years, and as Tom said, we have the test tools in place. We have the raw material in place. Of course, we can produce test parts. We have own tools where we can just produce a demonstrator for somebody maybe asking for a budget at his boss or at his company. And after that, we can support with the scale up. And we also have, meanwhile, very elaborated calculations which compare dry fiber costs to wet fiber and to thermoforming as well. So the customer, I think, has a very good base for making decision after that calculation. Of course, you cannot say if it's 100% match, because the calculation is always a glance of one point in time. Cost of dry fiber material will develop when the scale is reached for mass production. Cost of plastic may rise due to taxes and waste cost and CO2 footprint cost, as, for instance. So the price point is only a snapshot. And we are working on that every week, every day, to adjust our calculations and give the customer a good base for decision making.
If producers or OEMs, brands and brand ambassadors would like advice on dry fiber or how they would start, where do they start, Tom?
I think the simple aspect of that is to try and get us involved as early as possible, even if it's a concept, an idea, or they're trying to look and navigate the complexity of it. The quicker they can get us into those conversations, the more we can sort of guide them in the right ways. And then we can get them out into Germany. They can come and see some of the technology here. They can come and see the product lab. We can then start talking about drawings and so on to help them bring that product that they're trying to do into a realistic production environment.
Bias?
Yes, an easy summary. Don't try it alone. Team up with innovators on that case, because dry fiber is not just a new material, it's a new approach of producing form parts. And we have gathered a lot of experience in the past years, and we can help from the machine automation perspective. We can help from the material perspective. We have the context to do this. And the successful projects are not that ones that simply swap the material. These are the projects that are looked as a development project at.
For those that have found this interesting or would like to know more about dry fiber or any other form of packaging solutions that ILLIG are responsible for, I will put the German and the UK site at the end on the end slide, and also links to how to contact Tobias and Tom on LinkedIn. Thanks for watching.